to draw the structure of inorganic compounds having single central atom. Any doubt from the previous class? Okay. Savage, are you there? Right topic. The structure of molecule containing two central atom. Two central atom. Faiza, am I audible to you?
Yes, sir.
So in the previous class, we discussed about the structure of molecule having only one central atom. And today we are going to discuss about the structure of molecules having two central atoms. So there are two cases of this in which we are going to deal with the case one. Please do write with me. If there are two central atoms, if there are two central atoms and surrounding atoms, usually oxygen, surrounding atoms, usually oxygen present if it is in odd number, if it is in odd number, then linkage is AOA. Generally, the compounds which have two central atoms, they are surrounded by oxygen. And we divide this rule on the basis of oxygen. If oxygen is in odd number, then the linkage will be, AOA. I'm going to take an example. It's very easy to understand. Let's say we have Cl2O7. If you want to draw the structure of Cl2O7, it's very easy to draw. You can see two central atom, and which is the central atom? This is the chlorine, and oxygen is in odd number. So you are going to write ClOCl. Now you can see one of the oxygen comes here. Now we have 6 oxygen. So you are going to distribute this oxygen equally, 6 to the right oxygen and 3 oxygen to the right chlorine and 3 oxygen to the left chlorine. And since chlorine is third period element, so it has d orbital, so it can easily make double bond with oxygen. And you know that whenever oxygen is in surrounding, then it will make double bond. So this will be the structure of Cl2O7. Is that clear? You just need to go for oxygen. If it is in odd number, then the linkage will be AOA. And accordingly, you can draw the structure. Is that clear? Savage, Shahid, Arif? Please do respond, everyone.
Yes, sir, clear.
Sir, if we are using IUPAC common name, this is no. This is not organic compound. In organic compound, we have ROR, which is ethoxy or ether. Don't be confused. This is inorganic compound. Is that clear? Sorry.
Yes, sir.
Okay. Can I change the slide? Okay. I'm going to give you an example. See, the previous rule will be followed. If I'm going to give you, write the structure of Mn2O7. Can you write the structure of Mn2O7? Just wait. Mn2O7. You just need to see how many oxygen are there. If it is odd number, then you have to remember the linkage and you can do this. So I'm going to explain this. You can see this is your central atom and this is in odd number. So this is the central atom MnOMn. Now you have 6 oxygen left. So 3 oxygen to this manganese on the right hand side and 3 oxygen to the right manganese and 3 oxygen to the left manganese. And oxygen, whenever it is in surrounding, whenever it is corner atom or surrounding atom, it will make double bond. So this will be the structure of the Mn2O7. Yes, Shahid, exactly. Can you draw the structure of Cl2O? Just wait a minute. Cl2O7 we did. Now draw the structure of Cr2O7 minus. If you remember the previous rules, you can easily do this. Everyone done with the Mn2O7? Everyone is done with Mn2O7, yes or no?
Yes, sir.
Okay. See Cr2O7. Who joined just? Madiha,
Yes,
please
sir.
do this. Madiha, we just started the structure, drawing the structure of inorganic compound. In the previous class, we did the compounds
yes, sir.
having single central atom, and today we are doing the compounds having 2 central atom. So I
Alright,
just
sir.
divided this into 2 cases. The first one is compounds having 2 central atom and oxygen is in odd number. And whenever oxygen is in odd number, the linkage will be AOA. This A stands for the central atom. You can see Mn2. This is the central atom. So MnOMn. Now you have 6 oxygen left because it was 7 and one of the oxygen comes between the 2 central atom. So you have 6 oxygen left. So just divide this 6 oxygen and whatever the oxygen you have left equally on the right manganese to the right manganese and to the left manganese, and you can do this easily. And you know that oxygen whenever will be surrounding atom or corner atom, it will make double bond. So please
Yes.
take a screenshot of this and then we
Okay.
will move to the next.
So
Yes, sorry. Nadia, are you done with the screenshot?
yes, sir.
Okay. Now see, I gave you this question. I'm going to explain this. Cr2O7 minus 2. You can see there are 2 central atom, which is chromium, and the oxygen is in odd number. So you just need to follow this. Make a linkage CrOCr. Okay, chromium. Now you have 6 oxygen left. So I'm going to give 3 oxygen to this right chromium and 3 oxygen to this left chromium. Also, there is negative charge. I told you in the previous class that if negative charge present on the compound and oxygen is present, then this oxygen, the negative charge will be on oxygen. And if negative charge present on the compound, and if there is no oxygen, then that negative charge will be on central atom. So please remember the rule. This is very important. So you can see negative charge is there and also oxygen is there. That means this negative charge will be on oxygen. So two negative charges there. So I'm going to give negative charge to one of the oxygen on the right and one of the oxygen on the left. Are you getting my point? Now, you can see whenever oxygen has negative charge, it makes single bond. Okay, and whenever oxygen is surrounding atom without negative charge, then it will make double bond. So this will be the structure of the Cr2O7 minus. Is that clear?
Yes, sir.
Okay. Moving to the next part. Oh, okay. I'm going to give you a very important question, N2O5. Please draw the structure of N2O5. And I know most of the student will do it wrong. Let me know when you are done with this, and then I will write the structure and match it. And let me know if you have done it correctly or incorrect. Done. Okay. I'm going to explain it. You can see two central atom, that is nitrogen and nitrogen, and oxygen is in odd number. So the linkage will be NON. Now you have 4 oxygen left. So I'm going to give 2 oxygen on the right hand side and 2 oxygen on the left hand side. And if you have done this, since the rule said that oxygen is in center corner atom or surrounding atom, then it will make double bond. Have any everyone has done like this? Yes or no? Faizat, Harif, Shavej, you are not audible. Madiha,
Yes. Yes, I understood.
I asked, have you wrote the structure like
Yeah,
this?
sir. It was the same, sir.
So what I want to say is that this is wrong. Why it is wrong? There is a reason behind it. This nitrogen is second period element, and it cannot make 5 bond. I already explained in the previous class that when you are going to do the configuration, it will be 1s2, 2s2, 2p3. 2D does not exist, so we are not going to discuss about the D because it will not exist for second shell. Now you can see 2s2, 2p3. So it will be like this. Now you can see, just wait a bit. You can see it has 3 unpaired electrons. So you can nitrogen can easily make 3 bond, and the 4th bond I discussed in the previous class, 4th bond will be coordinate bond. So total that maximum number of bond that nitrogen can make is 4. But if you are going to count here, then nitrogen is making 5 bond and 5 bond. That's why it is wrong. Nitrogen cannot form 5 bonds. Nitrogen is not pentavalent because it doesn't have d orbital. So how the structure will be drawn? You can see it will be like this. Again, the oxygen will be divided similar in the similar way. One of the oxygen will make double bond. Now you can see nitrogen is making already 3 bond. The 4th bond will be coordinate bond. As I already told you, nitrogen can make 4 bond easily. 3 bond from unpaired electron, and the 4th bond will be what? Coordinate bond. So the structure of N2O5 will be like this, and it is very, very important. You will know the importance of this structure when you are going to study the inorganic chemistry of class 12, like P block, D
Sir,
block. Yes.
Sir, if you are doing coordinate bonds, so it will not be negative.
Coordinate bond do not be negative. What does it mean?
Like there is a unequal pairing, sharing of electrons, so oxygen will not give a negative, not gain negative charge.
Actually, this bond shows that it is nitrogen is giving electron to oxygen. So it is already understood. Are you getting my point? This arrows.
Yes,
That's why we do not write negative or positive. Let me know when you are done with this. Done. And in your board, the maximum marks or weightage in chemistry, that P block carries the maximum weightage of the chemistry. Everyone done with this?
yes, sir.
Okay. Now see, I just discussed two central atom in which oxygen is in odd number. Now the case second says when oxygen is in even number. If the molecule, please do write with me. If the molecule contain two central atoms, two central atoms, and surrounding atoms, usually oxygen, present in even number. If oxygen is present in even number, then there are two cases. Either the linkage will be given by AA, or even or if it is in even number, the linkage either will be given by AOOA. What I want to say is that if you have two central atoms and oxygen is in even number, then either the linkage will be AA or either the linkage will be AOOA. Now, how you are going to recognize whether which linkage you are going to use? So it's very simple. When oxygen is greater than or equal to 8, then you are going to use this. And when oxygen is lesser than 8 in even number, then you are going to use this. Very simple. Are you getting my point? If
Yes, sir.
oxygen is in even number, you have two linkages, AA and another linkage, AOOA. For AA, if oxygen is 2, 4, 6, and for AOOA, the oxygen will be starting from 8, 10, 12. Generally, you will have 8 in your syllabus, so you don't need to worry about this. Today, we are also going to cover the hybridization, and this class, uh, almost this class, from the next class, we are going to cover the JEE previous PYQs of JEE of solution chapter. I will announce this, or either you will get message from the Learnivio. Please do let me know when you are done with this. Are you done with this, everyone?
Yes, sir.
Okay. Now, can you draw the structure of this N2O4? Very important compound.
Sir, finish.
See, I'm gonna draw the structure. It's very easy. You can see two central atom. You have oxygen is in even number and it is 4. So the linkage that I'm gonna use is this NN. AA linkage I'm gonna use according to the rule. Now you have 4 oxygen, so two to the this 2 oxygen on the right nitrogen and 2 oxygen on the left nitrogen. And again, if you are going to make this double bond, then it will be wrong because this nitrogen is making 5 bond and this nitrogen is also making 5 bonds, which will not be possible for nitrogen because it doesn't have d orbital. Okay, so the right or correct structure is this. Sorry, the right or correct structure is this. O O O O. One of the oxygen can make double bond with nitrogen. Now it's 3 bond. So the fourth bond will be coordinate bond. Please do write. Now I'm going to give you some oxo acids, which is very, very important. Please draw the structure of H4P2O6. So first of all, you are going to recognize the central atom. How many central atoms are there? 2 central atoms. Now you are going to see the oxygen. Don't look for any other thing. Recognize the central atom and go for oxygen directly. Now you can see even number of oxygen. So for even number, we have two linkages, either AA or either AOOA. Can anyone tell me which linkage we are going to use here? Faiza,
AA.
Saf, Madiha, Arif, which linkage? So AA linkage we are going to use. So you are going to write P, P. Now don't think about other elements. Think about only oxygen. Now what you are going to do, divide the oxygen equally to both phosphorus. Now you can see like this. Now you have 4 hydrogen as well. So what you are going to do, as you know that send non-metal oxygen hydrogen, that means it is oxy acid, and oxy acids of what? Phosphorus. So as I already told you in the previous class, for an oxy acid there must be at least one OH bond, at least one OH bond. So you have 4 hydrogen. So I'm going to give 2 hydrogen to the right phosphorus side and 2 hydrogen to this. Now you can see that when oxygen is in between two atoms, it will make single bond, and this can make double bond as well. So this will be the structure of H4P2O6. And I think it's clear to both all of you, right?
Yes, sir.
Yes, sir.
Okay. If it's clear, then draw the structure of H2S2O7. Also, draw the structure of H4P2O7. Everyone done with this? Yes or no? Yes, yes, Shahid. Everyone done with this? H2S2O7. I'm going to explain this. H2S2O7. First of all, you are going to look for the central atom. Hydrogen cannot be central atom. In the first rule, I had given you that fluorine and hydrogen can never be central atom. Always keep that in mind. Now you have two central atom and oxygen is in odd number. So the linkage will be AOA. Now what? It will be SOS. Now you have 6 oxygen left. So I'm going to divide this in equal part. 3 to the right sulfur and 3 to the left sulfur. Also hydrogen is there. So I'm going to give one hydrogen to the left hand side and one hydrogen to the right hand side. And you can see it will make single bond because oxygen is in between two atoms. And this can be double bond, double bond, and double. In the same way, if you are going for H4P2O7, it's very, very simple. So please do this H4P2O7. Can you do this? Yes or no?
Yes, sir.
Okay. Arif, Faiza, Shahid.
Yes.
I'm going to give you a very easy question on this. I will give you the concept as well. But first, you are going to do the structure of this. Then I'm going to ask you. Everyone done this with this H4P2O7? Okay, again, see, this is the central atom and oxygen is in odd number. So the linkage will be POP. Simple. You have 6 oxygen left. You are going to do this. Now you have additional 4 hydrogen. So you are going to distribute like this. Wait a minute. Okay, can you see the screen? Everyone? Now hydrogen, 2 hydrogen to the left hand side and 2 hydrogen to the right hand side. So whenever oxygen is in between two atoms, it will make single bond. and corner atom double bond. So this will be the structure of this. Is that clear, everyone?
Yes, sir.
Okay, I'm gonna give you a very important concept, and this concept is very, very important, most important. If in inorganic compounds, the examiner will ask you about the reducing property or reducing agent, which one of the following is the most reducing agent, or I'm going to write it Ra, that is reducing agent. Then what you need to do is the one which has maximum bond of EH. E stand for non-metal or central atom. Maximum bond. Like if I'm gonna ask you which one of the following out of this three, H3PO4, H3PO3, and H3PO2, the most reducing agent, the most reducing property, or the most reducing agent, which one of the following out of these three? So this question will be solved by drawing the structure. If you are going to draw the structure like we did in the previous class, you can see it will be like this. For this, you are going to draw the structure. It will be like this. If you have remembered, if you are going to draw the structure of H3PO2, it will be like this. So you can see phosphorus is the non-metal or the central atom, which is directly connected to two hydrogen, or there are two EH bond and there is one EH bond. E stand for the non-metal. So the one which is having the maximum EH bond will be the most reducing agent or contains most reducing character. Are you getting my point? Yes or no? Faiza, Mohammed Harif, Savage, Madiha.
Sir, means it will reduce others, like it will lose hydrogen.
Can you repeat it again?
It will lose hydrogen. That means.
Yes. Yeah.
To
What
to
you
reduce
need to
the.
see is, just wait a minute. What you need to see is non-metal directly connected with hydrogen. The compound in which this bond will be maximum will have the most reducing property, or will be the maximum, or will be the most powerful reducing agent. Are you getting my point?
Yes, sir.
Shahid, Shahid, please do respond.
Yes, sir.
Okay, so if anyone haven't got it yet, just let me know. I will again explain it. I will again say the sentence. It's very easy. I'm gonna repeat it. Non-metal directly connected with hydrogen. The compound in which these bonds will be maximum will be have the maximum reducing property, or will be the maximum reducing agent. Let me know when you are done with this. Everyone done with this? Shavej, are you done with this? Arif?
Yes.
Okay. Please do this first. You need to draw the structure and count the number of pH bond or EH bond. Any answer? The strongest reducing property you need to tell me. Oh, very good, Shahid. After drawing a structure, you can easily find out the answer. Very good, Tharif. Any answer from Faiza and Madiha? If you don't get it, just let me know. We'll explain this. See, very good, Faiza. Okay, I'll explain it. Just wait a minute. And okay, so Madhya, what I told you, to calculate or to know the strongest reducing property, you need to draw the structure and you need
Sir,
to see how many bonds is directly connected with hydrogen. Yes, Savez, have you said anything?
is it D?
Yes, it is. So if you are going to see this H3PO4, you know the structure is like this. I just drawed this here. This is the structure. If you are going to see the structure of this, you know the structure will be like this. I also, you have drawn it in your notes, you know that. And if you are going to write the structure of this, here is the structure of H3PO3. And for H3PO2, you know the structure is also drawn above. To calculate the, to know the reducing agent or reducing property, what I told you, central atom directly connected with hydrogen. In here, zero bond like this. pH bond is 0. Here, pH bond, again, pH bond is 0. Here, pH bond is 1. And here, the pH bond is 2. Central atom directly connected with hydrogen. So, maximum pH bond or central atom directly connected with hydrogen, then This will be the most reducing probability. This will have the most reducing probability. Madhya, have you got it?
Yes, sir. Got it.
Please do write it. I'm gonna give you another question. Question is similar. You can see only the year changes, but the question is same. In here, they ask you about the strongest reducing property, and here it has been directly asked the hydrogen maximum number of hydrogen directly attached to phosphorus. Directly attached to phosphorus. Madiha and Shahid.
Sir, is it C?
Not C. If you are going to draw the structure, you can see as 4P2O7 is here, in which you can see oxy acid has the maximum number of hydrogens directly attached to phosphorus. So there is no pH bond. pH bond is 0. If you are going for H3PO3, you can see this is the structure of H3PO3 in which pH bond is 1. H3PO4, you can see pH bond is equal to 0. But H3PO2 in which pH bond is 2. So the maximum, the answer will be B. And Faiza, you are right. Madiha,
Yes, sir.
are you facing problem in this type of question?
No, sir. Now, like, understand.
Okay. Please do this question. Just wait a minute, it's not working. Any answer? Okay, I'm going to explain it. Very good, Shahid. I'll just check it. So for H4P2O5, you need to calculate the oxidation state of phosphorus. So first of all, I'm going to take the oxidation state of phosphorus is X. And since there is two phosphorus, so it will be 2X plus 4 hydrogen is there, and each hydrogen will have plus 1 oxidation state plus 5 oxygen is there, and each oxygen will have minus 2 oxidation state. So it will be equal to 0. It will be equal to 0. And you can see 4 plus 2x minus 10 will be equal to 0. And 2x minus 6 will be equal to 0. And 2x is equal to 6. So x will be equal to plus 3. So you are going to check in the option plus 3, you have two options. Now going for the second one, which compound it is H4P2O6. H4P2O6, and we need to calculate the oxidation state of phosphorus. So it will be again 2x plus 4 into hydrogen has plus 1 oxidation state plus 6 oxygen is there, and oxygen has minus 2 oxidation state. Overall charge 0, so it will be equal to 0. Again, you just need to simplify it and you will get your answer. You can see it will be 2x minus 8 will be equal to 0. So 2x will be 8 and x will be equal to plus 4. Now you can see in the option the H4P2O6 is plus 5 given. So it is not correct. So plus 4. And you can easily calculate this. So the answer is option D. Is that clear, everyone?
Yes, sir.
So please do write it. In the next class, most probably, we are going to do questions on solution. First, you are going to write it. Then I will tell you the topic and you are going to revise it before the class and make a good revision so that you will be able to do the questions of JEE Mains. Everyone done with this? Faiza, are you done with this? Madiha? Okay, so this is it for today. And in the next class, I'm going to give you some homework to do revision. And that one is from solution. We are going to start from solution. And the questions will be on concentration terms, that is weight by weight, weight by volume, molality, normality, and ppm. The second, you are going to do the solubility, in which Henry's law is also Henry's law. And the next one is your Rawls law. Rawls law. Rawls law, ideal and non-ideal solution as well. So you have 1 week, and I think you can do these topics easily. So in the next class, we are going to do only the questions. Only questions we are going to solve here. If you will have any doubt in any topics related to this or from this, I will explain that. Okay, is